Okay, it's 5 o'clock, which means that it's time for us to start the last session. This session will be led by Principal Researcher Kang Hee-jin of CRISO. So, sir, please.
I'm Hee-jin Kang, working at CRISO in Korea, and session chair of this session, last session of this day. And our session will start with Edmund Hughes is an engineer with expertise in engineering design and systems failure, and with years of expertise in maritime policy development. Please, Edmund Hughes.
Hello everyone, my name is Edmund Hughes, and it's a great pleasure to be with you today to provide a presentation on the outcome of MEPC 80 in July, and specifically the adoption of the 2023 IMO greenhouse gas strategy, which frankly is a momentous achievement and really a game changer for the global shipping industry. Firstly, may I thank the organisers of Digital at Sea Asia Pacific for inviting me to give this presentation, and may I apologise for not being with you in person. It's just that I have other commitments here in the UK this week. The IMO greenhouse gas strategy, as I said, momentous in terms of its adoption and gaining consensus by the membership of the International Maritime Organization, all 175 member governments, and as I said, there was no objections. It was by consensus, and really was a great achievement. As you can see, the resolution is 37780, and the strategy, after many years of renegotiation following the adoption of the initial strategy in 2018, ended up with a vision which was slightly different, amended from the vision that was adopted in 2018, and that says IMO remains committed to reducing GHG emissions from international shipping, and as a matter of urgency aims to phase them out as soon as possible, while promoting, in the context of this strategy, a just and equitable transition. And it's the last part of this vision that has been the amendment to what was agreed in 2018, to recognise, very importantly, that any action that's taken to implement the strategy, which after all is a policy framework, it isn't a mandatory requirement, but it's a policy framework for shipping going forward, that there should be a just and equitable transition, which essentially identifies that it has to be just for the countries and the seafarers who are, frankly, going to be implementing this strategy going forward. And this again was a key part of recognising that this has to be taken into account as we go forward with development of further mandatory measures to implement the strategy. In terms of the key part of the strategy, really, is the levels of ambition. This is the goals, the objectives, whatever you want to refer it to as, but the levels of ambition are really setting out really now the pathway for the energy transition of the international shipping sector going to 2050 and beyond. This was a key part of the negotiation, frankly, and a lot of time and effort was put into developing these provisions in this instrument. But to go into them in detail, the first paragraph, 3.1, again, this really was a building on what was put in the initial strategy in terms of recognising that any action going forward needed to recognise that those levels of ambition could only really be achieved, that there was a need for introduction globally, and that's a very, again, important part, not just in national or regionally, but globally, the availability of zero or near zero GHG emission technologies, fuels and or energy sources for international shipping. And this is fundamental, frankly, to help us achieve this significant energy transition in the sector. This will be a key part of what we need to now put in place over the coming decade to achieve these levels of ambition. Please also note that the term has been introduced of zero or near zero, Zero GHG emissions, I think that's fairly clear. Near zero, along with other terms within the strategy, weren't fully defined. I mean, that is part of for ongoing discussion, but it opens the door for, as I said, for further deliberation of what actually that term means. But again, it's very important to understand that the emphasis is on zero rather than near zero. 3.2, paragraph 3.2, again, is another important part of consideration when and again, part of the negotiation was a focus on making sure that whatever we do in shipping doesn't just lead to an increase in upstream emissions for the generation of the fuels or development of the technologies or whatever, the energy that is used by the sector doesn't lead to an increase in upstream emissions, because that would seem to be defeating the whole object of this exercise, that is to achieve the Paris climate goals. So here we see again the levels of ambition and indicative checkpoints should take into account well-to-wake greenhouse gas emissions of marine fuels. And this is fundamentally different to whatever's been really done at IMO before, where you look at all the current provisions in MARP Atlantic 6, which is the international requirements for reducing emissions from international shipping. The focus is on tank-to-wake emissions. So we look at what comes out of look at the fuel, we look at the standards for the fuel, but then the focus is very much on what's coming out of the exhaust from the ship. And this is really changing where we're going forward in terms of the fuels we use, to make sure that those fuels also take into account, and the emissions from the ships take into account the upstream aspect of emissions that are generated upstream from shipping. And then this is a really significant change, and one will have bigger implications as we go forward. And again, it recognises the development, a very important development within the IMO, of the LCA guidelines that have been now prepared and were adopted at this session on life cycle GHG intensity of marine fuels. And these have been adopted, but there is continued work on these and intersessionally going forward. But it does open up the whole possibility of using those guidelines now within the mandatory regulations that will be forthcoming. And again, the last sentence here is very important to note. With the overall objective of reducing GHG emissions within the boundaries of the energy system of international shipping and preventing a shift of emissions to other sectors. There was a significant debate and discussion about offsetting and whether offsetting should be permitted within the sector, and many governments felt that it shouldn't be, because they were concerned about, again, this business of just shifting the emissions from shipping out of sector. But other governments were keen to maintain that offsetting needed to be not completely discontinued or discounted at this stage, because of technologies that have been developed, including, very importantly, carbon capture and storage on board. And so there was, because at the moment there is no clear understanding of what the status of the carbon that would be captured on board the ship, for example, and how it then would be disposed of post capture on board the ship, and how that would be considered within a regulatory framework for shipping. There was a desire to maintain that offsetting shouldn't be explicitly excluded at this stage, and that there needed to be further deliberation of that as we go forward. So, but going on to the key levels of ambition which were adopted and agreed. You can see for the first one, the carbon intensity of ships to decline through further improvement of energy efficiency of new ships. This is a key, essentially was the same as what was in the previous strategy. However, there is no reference here now to the Energy Efficiency Design Index. There was when we first adopted the initial strategy, there was consideration of further phases of the EDI. That at the moment is still under deliberation, and so, but it was decided not to make an explicit reference to that here in this strategy this time. The second one, carbon intensity of international shipping to decline. Again, we have short-term measures which are looking at carbon intensity of shipping, such as the carbon intensity indicator. Again, this provided a key goal for that going forward, certainly as we look to strengthen the CII in this decade. and then keeping that at least 40% by 2030 compared to 2008 was seen as part of that consideration. Please also note, though, the 2050 goal of 70% striving or trying to get to a 70% reduction by 2050 was removed at this stage, probably and possibly again because of the consideration of other measures that may be forthcoming that may negate the need for such a goal now. Point 3, this is a new goal, uptake of zero or near zero GHG emission technologies, fuels and energy sources. It was seen as very important to have a clear goal for uptake of these new fuels, these new energy sources by 2030, because that is seen as the, if you like, the takeoff point for the industry when we will start really moving forward with the transition. And so having this at least 5%, striving for 10% goal of energy used by international shipping by 2030 was seen as a very important stepping stone. And then finally, the GHG emissions of international shipping to reach net zero. This is obviously new. It was at least 50% in the initial strategy, and now there is a clear focus on reaching net zero GHG emissions by or around, i.e. close to 2050. So a very, very important agreement of where the shipping sector should be going. And this was backed up by these indicative checkpoints, which are seen as very, very ambitious, but by many considered as necessary if we're going to be maintaining on track to the Paris climate goals. And here you can see the first one, to reduce the total annual GHG emissions from international shipping by at least 20%, striving for 30% by 2030 compared to 2008. And then to reduce the total annual GHG emissions from international shipping by at least 70%, striving for 80% compared to by 2040 compared to 2008. So these again are very, very ambitious indicative checkpoints. And when you think the 2041 is less than 17 years away now, it gives you some idea of the ambition that's been included in this strategy, and why now for all parts of the sector, all those who support the maritime sector, all industries, there is now a clear focus and clear sort of message that this is something that now has to be really taken forward very quickly and fast, and we have to really put in place now the measures to make this happen. This graphic from the ICCT gives some idea of what the implications of those indicative checkpoints and levels of ambition are for the sector, and you can see clearly what was business as usual was an increasing amount of emissions from the sector, whereas now the 2018 IMO strategy was as you said, as we said, it was at least 50%. But now with the 2023 strategy, you can see it going to net zero by 2050, and with those within the indicative checkpoints, the options for striving for greater ambition within the indicative checkpoints, leading to even a greater reduction of emissions. But what does that mean? Obviously, that taking those figures and seeing that steep decline in emissions from the sector, what does that mean in reality, and what are the implications for the sector? Well, we can certainly think about those in the near term, but obviously there's going to have long-term ramifications for the sector in terms of particularly the fuels that it will be using going forward. Just to overview just what are the other key decisions that were impacting GHG emissions that were made, and there were many made at MEPC 80, and it was a very, very important meeting for this in that regard. I've already mentioned the guidelines on life cycle GHG intensity of marine fuels, the LCA guidelines, and that resolution is 376/80. There was a circular on biofuels issued because there was, frankly, there was the treatment of biofuels by different flag states meant that we saw a different way of accounting for the biofuels when it came to data collection system and the declaration of emissions from ships, and that created concern that we were sort of leading to an uneven playing field with the use of these biofuels. So the circular that's been issued, and again, anyone who's looking at using biofuels or already using biofuels, I would urge you to review that, because it's very important in terms of how then those biofuels are taken into account when you make your reports under the data collection system to IMO. Again, as I mentioned already, onboard carbon capture and storage is to be considered now. There were many governments seeking for that to be looked at in earnest, and so it will now be considered by the next intersessional meeting, probably in spring 2024. But it is seen as a low priority item because there are many other items. But it's recognised that it is something now that needs to be taken forward on a mandatory basis and considered further. And there was also approval of draft amendments to IMO's data collection system, which again, it recognises there needs for potentially more greater granularity in the data that is collected and reported to enable greater analysis of the emissions from shipping. But again, that has just been approved and it will be adopted again at MEPC 81. But those amendments won't enter into force until late 2025, which means that importantly, for ships, they need to understand what is it they report now and what they will be reporting in future. But for any analysis that's done, it may be that we need to look at the data earlier, certainly when it comes to things like the review of the short-term measures, which I already mentioned has been initiated on particularly the carbon intensity indicator and the metrics that are used for that. What are the possible future changes to mandatory requirements? I've already mentioned regulating CO2 emissions, and we're not just going to cover CO2 now, but we'll be covering the well-to-wake emissions, particularly under CII, and then what are those, when we look at increasing and strengthening those requirements, how we build into that the well-to-wake consideration, which will now we have the guidelines enables us to do so. At the moment, there is very much soft enforcement of CII, the carbon intensity indicator, for those ships rating D and E, and the question will be, frankly, will that be acceptable going forward, and will there need to be a greater emphasis on how we make enforcement stronger and strengthen the enforcement on ships that are not complying with those ratings? Because after all, the policy goal is to reduce emissions from international shipping, and particularly now we have those greater ambition in the levels of ambition. From 2027, there is now a clear programme of work going forward to look at a global fuel standard, a GHG fuel standard for international shipping, and again, gradually reduce the allowable well-to-wake carbon intensity of marine fuels that can be used. There's also part of that consideration is some sort of flexible compliance approach to try and make sure that ships that can't buy or purchase the fuel that they need to comply with the requirement can find another alternative way of doing so. And there is a lot of work to be done on the details regarding that. And there's also the economic element of a basket of measures. I could spend whole presentation just talking about the economic element. The discussion there's been wide discussion on whether we should have a levy, whether there should be emission trading, whether there should be some other form of carbon pricing. Again, that is to be done, and it will be part of an overall consideration of these. Will be a comprehensive impact assessment that has been again initiated at MEPC 80 to look at those measures and look at the implications of those measures in terms of their impacts on states, which is a very important consideration for governments at the IMO. I've already talked about life cycle GHG carbon intensity guidelines and their implementation. Again, they refer in those guidelines specifically. They refer to a fuel labelling approach and looking at the bulk and delivery note potentially as the instrument to note, the type of fuels that are going to be delivered to the ship, and also one of the key questions for the ship industry in particular is how can the life cycle of fuels sold globally be effectively verified by ships? So a ship wants to purchase these required fuels, these compliant fuels. How will it do so? And again, and make sure that those fuels are what they are being sold as, because obviously, again, compliance will be critical for the vessel when it sails around the world and goes to any port and is subject to port state control. We've seen significant work done on the safety aspects of these, particularly the alternative fuels under the International Gas Fuels Code, and we know there's work ongoing there on methanol and ammonia and hydrogen. And in fact, there's been now a new output agreed by the Maritime Safety Committee at IMO on the development of a safety regulatory framework to support the reduction of GHG emissions from ships using new technologies and alternative fuels. And this is, frankly, a much more comprehensive framework of work that will look at the risks and how those risks might be mitigated for across the piece for these alternative fuels and energy sources that will be forthcoming to help achieve this 2023 strategy. And that work will begin in earnest when this output is added to the agenda of MEC in next year. And then finally, and not least, the human element, and this is reflected now in the 2023 strategy, and also we know that there's the Convention on Standards of Training, Certification, Watchkeeping (STCW) is under review to make sure that the seafarers are fully skilled to enable them to utilise these new technologies and fuels, and that again is a very important part of this whole part of this equation, and why, frankly, there's urgent action is needed across all regulatory frameworks, and again by administrations, by the ship owners, by the shipbuilders, to understand what these risks are going to be and how we can therefore, and obviously the training institutions, the colleges, and everyone, and frankly every stakeholder who has a role to play here in terms of delivering this very ambitious 2023 strategy. And then finally, just the implications, which I haven't got time to go into a great deal of detail, and I'll leave you to scrutinise this slide at your leisure. But frankly, looking at the indicative checkpoints, which I mentioned earlier, I mean, the 30% reduction, if that's the striving for 30% by 2030, that means, based on the greenhouse gas study that was done by IMO in 2019, that means an 88 million tonne fuel oil reduction from the sector, which is significant in its own right, frankly. But if you look at it for 2040, you're looking at 235 million tonne fuel oil reduction by 2040. So as I said, in less than 17 years, which is when you think about it, is very, very significant and very, very ambitious. And when you think, and this is based on some of my own analysis, that equates to approximately, and I mean very approximately because there's all sorts of factors affecting the fuels. But if you just to take methanol, for example, as an alternative fuel, you're looking at something like 470 million tonnes of methanol, 500 million tonnes of methanol as an alternative fuel to replace that fuel oil that will no longer be permitted. And then you've got to think about the carbon, obviously, from the methanol, where you're looking at green methanol and perhaps even carbon capture on board as well. So there is a significant, just alone, it shows you how the significant challenge here from this instrument, this revision of this strategy is. Things like who's responsible for CII. This is going to get increasingly more of an issue commercially, because CII will be looked at by charterers increasingly, and then that has a knock-on effect to things like the company strategy for new ships, and whether you buy now or whether you wait and retrofit. This is all going to have to be thought about over the next few years, frankly, because these are all risks that are coming down the line to the industry that needs to be understood and fully appraised. Data collection, storage, management, analysis and transfer of the data is going to get increasingly more important for analysis, and that then leads to obviously questions about cybersecurity and transferring that data. Again, a critical risk that has to be considered. Audit trails for the irrigation of fuels I mentioned earlier. If we're looking at upstream emissions, people want to know where these fuels are from, how they're audited, making sure they're verified properly that they are what they are. Again, increasing scrutiny on that. The Scope 3 emissions increasingly scrutinised by the cargo owners. The cargo owners are becoming very, very active in terms of pushing the industry to go to net zero, and we're seeing various initiatives by the cargo owners, people who purchase the slots on ships, saying, well, we want to know, what these ships are, and we certainly want them to be net zero, as soon as possible, because we have to account for that in our business practices under Scope 3 emissions. Very important, I would suggest, the selection of counterparties now is growing increasingly critical. It's not an isolated decision. When you make a decision about which ship you're going to purchase and how you're going to build it and where you're going to build it and who's going to car charter it, these are all decisions that, frankly, you're going to need to sit down with your counterparties and really work out collectively rather than be in a silo, because they're going to, there has to be some sort of sharing of risk going forward, frankly. The cost of compliance is going to grow, so regulations are frankly going to get more complex, and it's going to cost more to comply with them because of that complexity. So more effort will need to be thought about on how we do that. There's increasing legal risks. We're seeing claims by companies and businesses be challenged in courts around the world by various jurisdictions where people can say, well, we're doing this, and their shareholders, they have active shareholders who say, well, actually, we don't believe it, and they take them to court over it. And again, this is becoming, we're seeing increasing challenges to claims of achieving, green goals. And then that will have a knock-on effect to the boardroom in many companies, because they'll be aware of that risk, and they'll need to therefore make sure that they can clearly understand those risks, which means reporting, transparency, scrutiny, frankly. And then just to finalise, for me, the three key drivers for change: the ship, the fuels, and the cargo. And they are the three things you really need to think about from whatever your perspective in this industry is. However you engage with the shipping sector, you have to think about it from those perspectives, and including the ships, it would certainly include the human element and the seafarer. Thank you very much indeed for your time today and your attention. I appreciate that. I've gone over time a bit, but this is obviously a very important subject. Thank you.
Thank you, Dr. Hughes. I'm impressed by your presentation, especially on mandatory requirements and implication. Anyway, time goes up. I directly invite second speaker, Dr. Song Kang-hyun from Korea Register of Shipping, Senior Vice President. Please.
Thank you, Dr. Kang. Good afternoon, all. It's my great honor to make presentation in this wonderful conference. Already addressed in opening and the previous presentation, the most important topics of maritime industry is decarbonization and digitalization. So in this presentation, I will focus on how to achieve decarbonization by digitalization technology. So I believe that the decarbonization is a goal we have to achieve, and the digitalization is a tool to improve the efficiency. Yes, already introduced by a previous presentation, IMO made one of the most historical decisions 2 months ago. That is 2050 carbon neutrality. It will make a huge impact on the shipping and shipbuilding industry. And Clarkson expected that by 2050, the zero carbon fuel will occupy 85%, and we cannot see any HFO, the conventional fossil fuel. And the IMO regulation will be strengthened year by year gradually. Let's look at the EU GHG policy. Its policy, the ambitious level, is much higher than the IMO. So it already adopted carbon neutrality 3 years ago, and the GHG reduction target is 50% by 2030, while the IMO target is 20% to 30%. And the shipping sector will be included EU ETS, and the FuelEU Maritime will be brought into force from 2024, while IMO still under development, there's a similar regulation. And the United States also start to discuss about the U.S. Clean Shipping Act from this year in U.S. Congress. The ambitious level is much higher than IMO and EU. I will process very fast. So, and also, furthermore, this regulatory regulation, the private initiative from bank and the insurance company and the cargo owner is much more critical to the ship owner. For example, the COSEP, the International Association of Cargo Owners, declare by 2030, we aim to only purchase ocean freight service powered by zero carbon fuels. So all this regulatory body and the private initiative push the shipping industry to use zero carbon fuel. This shows a very complicated chart, but this shows the all regulation the ship comply with. But it is very almost impossible for individual company respond to all this regulation, because, for example, the FuelEU Maritime, it consists of 800 pages, and it has several annexes. So we provide the one-stop regulation solution service called the Care Gears. So the owner can check easily the compliance of this regulation, and also this software calculate how much the carbon penalty or carbon price the ship owner should pay. Then I will move on to CII. Experts say the CII, the EXI is the first wave of decarbonization, and CII is the second wave. And the third wave, someone say the original wave was tsunami. It is a market-based measure called the GHG fuel standard. And the CII normally is calculated based on the annual fuel consumption of a previous year. And it stands for actual fuel efficiency of each ship. And it is strongly coupled with the upcoming GFS. So CII is one of the most important index. We carried out the CII ratings for 1,700 ships. More than 60% is neither the Korean flag nor the KR registered ships. So I believe that it stands for quite general statistics. You can see that the C-rated ships, largest number, followed by D and B and E and A. Also, the lower graph show the CII rating according to the travel distance and the deadweight. Please pay attention to the red color. It is a E-rated ships. The number decrease gradually according to the travel distance and deadweight. It means that the smaller ship with a short voyage get a worse CII, while the larger ship with a long voyage get the better CII. So many ship owners say it is not unfair. It is like a car driving in a city and or highway. So fortunately, this kind of drawback already recognized by IMO, and from next year, IMO will develop the correction factor to compensate this short voyage effect. And this shows the CII ratings for each ship type. For all ship case, the C, D, E rated ships is almost 70%. The CII criteria is strengthened every year. So if there is no measure, the C-rated ship will be vulnerable to be rated D. So it means that this 70% of ship need a proper action right now. So this decarbonization issue is a big challenge for ship owner. Not only the individual company or Korea shipping industry, but it is a challenging issue for all global shipping industry. Then what can we do with this single value of CII? You can see the vessel 1, it is a feeder container. It is rated B, but you can see there is several ships got the better CII. Then how? We look into the DCS data. The vessel 1 rated B and vessel 2 is rated A. But please pay attention to the speed. The vessel 2 was operated in a lower speed. The speed is very important because the CII and the fuel consumption is proportional to the square of speed. And then what can we do if daily fuel oil consumption data are provided? Some company provide us this DFOC data. So you can see that this graph is speed and DFOC curve, and the blue line is a DFOC curve from a sea trial, so the new building condition. And you can see many a red dot. It is maybe 365 dot because it is a daily fuel oil consumption. And we can drive this green line by averaging. So it means that we can exactly understand the relationship between the speed and the DFOC. Then we can expect how much the ship speed should be reduced to save a certain amount of fuel consumption or to keep the CII rate. Then this is example of a CII simulation to keep a C rate by speed reduction with the biofuel blending. So the CII, I already say that the CII criteria is strengthened every year. So, for example, this ship starts from the 16.2 knot, and the ship should be gradually decreased to keep a C rate. And there is a limitation of speed from business point of view. Then in some year, the owner should start to blend the biofuel from the 2%, 15, 13, and 40%. The problem of biofuel is that it is very expensive, or almost 3 times expensive than the conventional fuels. So the owner should want to save a drop of fuel. So then the owner can consider installation of energy saving device or onboard carbon capture system. So through this kind of simulation, the ship owner can develop the management plan for their whole fleet. Then what can I do if we have more detailed data like a shaft power curve? So this graph shows the speed power curve. The black dot line is from the sea trial, and the blue line, we get rid of some unstable data, and we can drive this green line. Green line means performance curve at present. So the difference of these two curves means some performance degradation from such as the fouling or engine or propeller aging. So if we know exactly this degradation, the owner can make optimum maintenance plan in a cost-effective way. So also we co-work with the data provider. This company provides us all AIS data and environment condition. It means that we have every data. So we can carry out the root cause analysis for bad CII and provide the optimum operational measure. So this is my intermediate conclusion. More data with good quality support better decision. To do that, the ship should become smarter. There are many definitions of smart ships, but in the view of decarbonization, I believe the smarter ship means the ship she understands how much energy she used for main propulsion or generator or boiler or harbor operation, and also she knows how to reduce or how to improve the fuel efficiency, like avoiding a harsh environment condition or cleaning or trim or speed optimization like that. So the shipping industry and shipbuilding industry should collaborate to do this. And I will move on to alternative fuel and novel technology. I visited many ship owners, not only the Korea but all globally. Then the most frequently asked question is what kind of alternative fuel we choose. But yeah, the question is very simple, but it is very difficult to answer because the big shipping company like Maersk or CGM or HMM carry out comprehensive study to find out the solution. So I will show our result. So we choose the 8,000 TEU container ships. We consider several alternative fuel like HA4, LNG, methanol, and ammonia. We assume the transition in 2030, and we simulate 25 years. Then we consider CAPEX and OPEX. For OPEX, the most influencing factor is the fuel price and the carbon tax. So if the owner chooses ammonia, then the fuel price is very high, but the carbon penalty is very, very low. The owner chooses the HFO, the fuel price is very low, then they should pay a huge amount of carbon tax. So we consider all this factor. So this is a conclusion. the best answer is LNG fuel with the blending of bio-LNG. But we carried out several comparative study and the answer is that there is no fixed answer. For small handy-max ships, the best answer is the steel HFO with the biofuel blending. For VLCC, the best answer is LNG with the ammonia ready or methanol. Because there is also the big uncertainty in the prediction of the fuel price. The price scatter very much, and also there's an uncertainty of the carbon tax. The carbon tax is still under development in IMO. So we make some assumption, most probable assumption. So if we make a different assumption, then the optimal solution can vary. So our conclusion is that the answer is differ from each ship. There's no general answer. Also, a lot of energy-saving device, innovative technology are developed. So we are craftsman society. We focus on the safety side, but also we focus on the performance because many technical providers overestimate their performance. So we try to verify as a third party. And also onboard carbon capture system can be one of the best candidate to reduce the GHG. So this is my last slide. From this year, we establishing a comprehensive GHG compliance center, and it is supported by Ministry of Fishery and Ocean and Fishery, and it's almost a $25 million project. And it has 3 steps. The first one, we will develop the database for all decarbonization technology from the alternative fuel, energy-saving device. And the second step, we will check the regulation compliance and also carry out the gap analysis and calculate how much carbon price the owner should pay. And we then develop the optimum technical measure. And the third step is that we will collect data from the ships and we will provide the optimum operational measure. So it is not done by only the KR. We co-work with the various stakeholders like shipbuilder and the shipping company and government and also technical provider. So actually, for this project, KL take a role of coordinator. So I'd like to finish my presentation with this phrase, 2D with the 2C. It means that decarbonization and digitalization can be achieved by cooperation and communication. Thank you for your attention.
Thank you, Dr. Song. Hello again. To save this session, we just have 10 minutes. 15 minutes. So I briefly introduce and discuss about future green ship and maritime digital technology. In the shipbuilding industry, there has been a concentrated focus on digitalization using digitized data and information for over the past 20 years, with PDM and PRM serving as example. On the other hand, digital transformation should aim to expand the scope of digitalization into new business models. Up to now, digitalization, I use the term digitalization, in the maritime sector has primarily focused on developing ships with superior quality, low cost and short lead times, centered around the shipbuilding industry. However, digital transformation will serve as a new leverage point to broaden the horizon of maritime carbon neutrality, I think. Until the introduction of EDI in 2013, carbon emission reduction was often seen as the sole responsibility of shipyards when developing new vessels. However, the introduction of EXI and CII, which apply to vessels in operation starting this year, has had a direct impact on shipping industry, as you know. The use of carbon neutral fuels like green methanol is intertwined with market-based measures and life cycle assessment. And it will also have a significant impact on the energy industry. Last year, Korea decided to establish the green shipping corridor connecting Busan and Tacoma with the United States. This green shipping corridor will serve as a debut stage for various carbon reduction and carbon neutral technologies. Diverse innovative technologies will create new markets, and each of these technologies will be validated for their carbon reduction effect based on proven digitalized process and data information. But as we know and as we understand, there are still technical and economic hurdles when it comes to alternative fuels. However, any alternative fuel or carbon reduction technology, regardless of its nature, can only be incorporated into EDI, EXI, and CII formulas through objectively validated data, information, with the consensus of nations. The various measures to achieve net zero will be validated for their effectiveness through proven data and information derived during the digitalized implementation process. As you can see, technologies for reducing carbon emissions in ships have overlapping components, and making challenging to achieve a simple cumulative carbon reduction effect. In other words, there is a need for an objective and verifiable method to assess the carbon emission reduction effect of ships that apply various technologies in combination. This is why I consider, and we consider, digitalization in shipbuilding and shipping industries as a crucial from a decarbonization perspective. CRISO, where I work, is currently developing various digitalization technologies, and also in the process of developing the alternative fuels demonstration ship called Korea Green Ship Testbed, KGTB. Ultimately, CRISO plans to collaborate with the international community to carry out the validation and standardization of carbon neutral technologies with digitalized data and information. For your information, KGTB is a 2,600 GT class ship with 2.2 megawatt of propulsion power for 12 knots. KGTB utilizes direct current distribution panel to share propulsion power load between main generator and the verification power sources, such as batteries, marine batteries, fuel cells, and carbon neutral fuel basis internal combustion engines. CRISO plans to join the international community in assuring in the net zero era by quantitatively measuring carbon emission reduction effects, verifying reliability and safety of brand new net zero technologies. KGTB is scheduled to be launched in 2024 with a full-scale operation planned to commence in 2025. Maritime decarbonization is set to align with the overall trend toward electrification, given the growing economic viability of marine batteries and fuel cells, and the increasing adoption of carbon neutral fuels, anticipating accelerated hybridization and electrification of ships, I think. For this reason, in Korea, CRISO and KERI are in the process of establishing the world's largest on-land-based 30 megawatt class electric propulsion system testing and evaluation facilities. CRISO will engage in simultaneous collaboration with long-distance manufacturers and equipment suppliers by using digitalized data and information, such as including cyber-physical system technology. This diagram you see represents the testing area of a 30 megawatt class electric propulsion system testing and evaluation facility. Through the sharing and utilization of digitalized data and information, long-distance cooperation among companies, organizations, and nations becomes possible, hopefully, in the future. Hopefully, until end of 2025. This will contribute to the development of various electric and hybrid vessels and realization of net zero. The digital data and information network, bridging shipyard equipment manufacturers, shipping, and energy companies will serve a catalyst for creating new industry and job opportunities that we haven't previously considered. CRISO is a national research institution, and we share our research process and result via international community such as IMO. So I would like to invite you all to share our study result and contents. Maritime net zero is not a task, I understand, and we know that can be achieved by a single company, organization, or nation. I would like to emphasize that above all, the role of digital transformation is crucial in the sustainable participation, development, and achievement of companies, organizations, and nations in realizing maritime net zero. CRISO, including myself, will support the establishment of a systematic roadmap for achieving maritime net zero and will endeavor to facilitate cross-national cooperation. And this is my last page, and I would like to share my concept of maritime net zero with this image figure. Through digital transformation, we can achieve the tangible value of net zero rather than it just being a concept. Thank you for attending. Thank you. I think we just have 5 minutes for this session. So I would like to inquire with Mr. Tommy Rasmussen from MAN. Tommy?
Yes.
The market is anticipating the availability of MAN's ammonia brand new engine system. And I would like to inquire, how do you and MAN plan to control emissions of nitrous oxide and NOx related problems? And are there any plans to incorporate or utilize digital technologies for this control?
Yes. First of all, we control the N2O by the tuning of the engine. And already, I think the auto-tuning of the engine, as we call it, that was introduced, I think, almost 10 years ago. So by applying this feature into the control system, we can control the N2O. And regarding ammonia slip and NOxes, we already, many years ago, introduced what we call the SCR that will treat the exhaust gas, taking care of the ammonia slip and the NOxes.
Then when you expect to reveal your own product?
Yeah. The first test on our test engine, on our R&D engine in Copenhagen, that's a quite small engine, but it's a 4-cylinder 50-bore engine that was already running on ammonia here in July this year, but on 1 cylinder. And that engine is now undertaking retrofit, so it will be running on all 4 cylinders within this year. Then what next step will be that next year, by the end of next year, the first commercial engine will be running on ammonia here in Korea. And that engine will be delivered to the shipyard by the end of 2024, by the end of next year. And the vessel will enter service in most likely in the beginning of 2026. So it's already, how can I say, well managed, the introduction of the ammonia engine.
Thank you very much for your insightful comments. And Dr. Song, I would like to inquire about there are some argue that development of classification rules for the approval of new technology for net zero. There are some argue classification societies have to make new rules for new technology. There needs more faster process of rule making. How do you plan? You already introduced KR gears, please.
You are pushing me. Actually, when you say the decarbonization, we've never experienced this alternative fuel like ammonia and methanol or hydrogen or battery or a lot of novel technology under development. But the new technology means this implies a potential risk of accident. So we really focus on the developing the regulation for this. But actually the rule making process is totally different from the past. Because for LNG regulation, there were already a lot of LNG fueled ships operated. Then the rule came out. But for ammonia case, the industry require IACS or IMO to develop the criteria based on they can develop the ammonia engine or scrub SCR like that. So we try to develop this rule and regulation ASAP.
Thank you. Can I have more time? Time's up.
Well, about 2 minutes.
2 minutes, thank you. Dr. Hughes? Dr. Hughes there? Are there?
Yeah, I don't think he's here with us.
Thank you.
Yes, then we're going to end that session. Why don't we give all the gentlemen a big round of applause? Thank you very much. Yes, that was the last session prepared for the day. However, we have day 2 tomorrow waiting for you. We'll be starting at 10 o'clock tomorrow. And I know that there is the banquet prepared for all of us to enjoy at the night. So those who wishes to join us for the banquet, you're welcome to join us on the 19th floor, the Namsan room, as we will be beginning soon. So I recommend you to pack your things and go up to 19th floor right away. With that, we're going to end the day 1 at the Digital at Sea Asia Pacific Conference. Thank you very much.